I will talk about 3 different ways of establishing the connection between objects that we all know, the globe, the planet, the Earth, but trying to differentiate their meaning for reasons which have to do with science and also with politics. So this is why I will try to move through different ways to establish connection, as the President says, between different fields of your university, engineering and science and social sciences, which is my original field. So the part 1 would be to try to understand in what way what I call the ecological mutation modify the goal and the very definition of politics and social sciences. When I say mutation, it's to avoid the word crisis, because when we talk about an ecological crisis, we mean that we could get out of it, but we won't. It's not something which is going to pass. We are going to mutate into a very, very different situation, a situation which requires a different way of understanding science, technology, and politics, because it requires a different way of being on this earth. So this is why we'll use the word mutation and not the word crisis. One way to specify this mutation is to propose that we, meaning all the nations of the world, and every one of us personally, are submitted to 3 disorientations, which is the reason why we have so much difficulty in defining our ways of organizing our thought and also organizing the institutions of our polity. The first is a disorientation in time, and that's the theme which I'm sure many of you know, called the Anthropocene. Even though it's a disputed term, I will use it positively as a way to define what I call the new climatic regime. So it's not just about climate, it's about the whole change in our way to be connected to the Earth. The disorientation in space, which is the one I want to insist most on. We don't know where we are. And the most troubling one, the one which requires the competence of historians, social scientists, political scientists, is the disorientation in agency. Agency is a term we discussed with our translator before, which just means the way we can, what can we expect from humans. So it's a simple term. Who we are if we live in the Anthropocene on a different Earth, that's the question I want to raise with you. It's a big question, but it has consequences on all the different fields for a reason which I will show before. And the reason which we are most disoriented in agency is because we have to link the history of humans with the history of the Earth. This is why the word has been introduced of geohistory. So historical teaching has to be modified accordingly. First, disorientation in time. There is a dispute around the date and the exact nature of this term, Anthropocene, which has been offered to the world by climatologists, chemists, especially Crutzen, and many others. And this term defines, as it says in Chinese, the time of the human, which is very strange translation, because the word Anthropocene also means that the human, which is the Greek anthropos, is actually a geological force. That you, I mean, not you personally, but all of you together, human, we the human, we mold the landscape of the earth that we knew, but we also move, and that's more embarrassing, the earth as a system, as it is understood by geologists and climatologists. It does not just mean we move the environment. We have been moving the environment for hundreds and thousands of years, but that since, some people say, like those publishing this paper, since 1945, we actually modify the Earth system. So we push the Earth system in a different regime. This is disputed, but the dispute is interesting because it forces the social sciences to do a deep revision of their own understanding. This is a diagram like the diagram you learn at school to know where you are in this long history of geology. And I'm sure you learn long historical period of the Earth system, and this is what was called geological time, very long time. But the funny thing is that the Anthropocene, this is here. It's so thin that it's actually invisible here in this diagram. It's just a geological bed, so small. Probably there is a dispute, 1945, maybe 1779, maybe 1610 there is a dispute. But it's a small period of time where the most important geological forces, according to Anthropocene people, is human technology, human science, human cities, human agriculture. Okay? Now, what is interesting is that I called here a poison gift, because it's a gift from the natural scientist to the social scientist, and the social scientists say, what are we going to do with this? We don't like to be in the geological repertoire, and the human and the social doesn't want to enter into this history of the Earth. So there's a big dispute among social scientists. What do you do with a concept like the Anthropocene coming from the natural sciences? And they argue many times that we don't want to enter this history of geology. We don't want to have such a strong force that we are able to modify the Earth system. So it's another dispute. There's a dispute among geologists, and then they say we are in the Anthropocene, and there's another dispute among social scientists about what to do with it, and they don't like to be part of that history. And some people in politics, especially in the United States, especially now that we have the President of the United States, Mr. Trump, who is a climato-negationist, they say we don't want to be part of that history at all. We are absolutely not concerned by the ecological. But the other part, which means that we are in that big story and history, is this other concept, which is also a poison gift, given also by natural scientists, especially by Crutzen, to the social scientists, called the Great Acceleration. Now, this is a very troubling diagram. If you look at this diagram, if you look at the bottom of it, this is, I was born in that little parallel, this time here, okay? When I was born, I'm a baby boomer, just after the war. This was the footprint of humans on Earth. And this is the footprint of humans nowadays, which means you are having a much bigger footprint than I had. And my generation, we had a great time. We occupied the Earth all the way to this huge place, to this huge dimension in population, in patents, and also in energy use. But the little difficulty, which is a generational difficulty, is that now we leave to you, the young kids, the task of cleaning this huge mess. So thank you very much. We had a great time. We developed the whole world, you especially in Taiwan, and now we are stuck with what people of my generation have done, and we politely leave you the responsibility of solving our problems. And we retire happily, which is not true. We retire with great anxiety and a feeling of guilt, which is hard not to have. But what's interesting is if we are in the Anthropocene, we are in this history. Now, the second disorientation is in space. Where are we? What is the land or the soil of the earth on which we reside? And one of the activists called Bill McKibben was so distressed by this different space that he titled his book with another term. The term is horrible actually, Earth, I don't know what one is. Making a life on a tough new planet. Now that's a very interesting term because it means that when you are a scientist or an activist working in the ecological mutation and you ask a very simple question, where are we? Suddenly people look around and say we are on a tough new planet. It's not the planet we had when I was born. It's not the planet of the beginning of development. It's a very different planet. The word is not going to last. Earth is a horrible word, but the concept is important. And people who work on this question of the Anthropocene try to draw something to understand the link between natural and social sciences that you all recognize, because basically it's Taiwan. Taiwan is a completely anthropocenic place. And some people use actually anthropocenic place, CSC. You see, it's all of the other questions, all the traditional questions, which are the question of natural sciences, what sort of soil we have, what sort of sea we have, what sort of air we are, plus all the socio-technical questions we now have about cities, agriculture, the whole infrastructure, industrial infrastructure, which is of course the same, which has the same consequences on the soil, on the ocean, and on the earth. That's what I mean by collaboration between the natural and the social sciences, because the soil, the land on which we begin to realize we will have to live, has a different aspect, and it has to be studied as a new territory. In the old days, in the 1980s, if we wanted to have a representation of the Earth as a natural phenomenon, we would use images like that. And we will begin, as many people do, I'm sure here, to measure up all the different circuit and cycle between trees, animal, soil, invertebrate, geochemical cycles. But as you see here in this image, there is no human. The humans are not represented there. They are not, this is pre-Anthropocene type of drawing. And now, of course, we live in a different situation where we have to be living with the third disorientation, which is the disorientation in agency. Now, I know that this is a hard slide for Taiwanese because precisely you were excluded from the COP 21st in Paris. And I'm sorry, and I apologize in the name of the United Nations for this forgetting. But the COP 21st was nonetheless a very important event because here you see the foreign minister of France and all of the people who had worked on the climate meeting and the signature of the climate treaties, precisely the treaties that Mr. Trump is trying to destroy, in a moment of joy, in a moment of sort of exhilaration because they managed these extraordinarily difficult treaties. But then, in the middle of this great sort of joy, there is a huge diplomatic tragedy. Fabius had asked, which is the name of the minister here, had asked every country minus Taiwan, to send what they call their intended national determined contribution. It's a United Nations sort of terrible acronyms, INDC, which meant that every nation had to say, this is the way I will use the earth in 30 years. So America did it, India did it, everybody did it. And when you put all of those together, all those propositions for using the earth and developing in 30 years, of course, the sum of all this INDC was that there was no earth corresponding to it at all. As you know, the calculation has been made. If we all wanted to be like American, we would need 5 Earths, okay? And we have only 1. So this is a very tragic moment. People are simultaneously saying, great, we have an agreement, and oops, we have only 1 Earth, and you, the people who applaud in the room, want 5. And that's very important because that's a disorientation in the goal of politics at large scale. We simultaneously know that there is 1 Earth and want to have 5, let's say. It's as simple as that. And that the disorientation is very well illustrated by the great book by Oliver Morton in this very puzzling sentence about the Anthropocene. The paradox in a nutshell is this: humans are grown so powerful that they have become a force of nature, and forces of nature are those things which, by definition, are beyond the powers of human to control. So this is the situation, the sort of double-bind situation in which we find ourselves. We have grown to the size of the forces of nature and simultaneously lost entirely the control of those very same forces. You see the paradox. Philosophically and politically, it's extremely troubling. We are given collectively the agency of being in power for the first time, molding the earth, and simultaneously withdraw this power by being a force of nature. And that's why we are all disoriented. And I'm just, for the students who are interested in this, signaling 2 very important books. One by French historians of environment, Bonneuil and Fressoz, and the one, probably some of you know it, by Chakrabarty, who is a great Marxist historian, who is the first to have linked the history of the earth with the history of humans. The situation is very well illustrated in this image from the page cover of Nature last year, when they did their big issue about the Anthropocene, and they called it the human epoch, which is slightly strange. And to illustrate it, they had this very strange figure that you see here, which is a sort of complete chaotic human blind, headless body, which is simultaneously filled in. If you see, there is a nuclear plant. Nuclear plant are here, mining, all sorts of things, which are put somewhat haphazardly on a body, which is a headless body, and the headless body is supposed to be our political institutions. Now, this is very interesting for a political philosopher, because this is, of course, an exact parallel with another image of a composite and collective body, very famous in political philosophy, which is the frontispiece of the cover, if you want, of Leviathan, the book by Thomas Hobbes. And it's another way of building the comparison between the invention of a nation state, which is Hobbes's Leviathan, after war, especially religious war, and now the completely chaotic situation in which we find ourselves at the time of the Anthropocene. And that's why we are fairly disoriented. But there is a great parallel in the two crises. The 17 crisis, it was a time of religious war after a complete breakdown of civic orders, after 200 years of religious war. It was also, very importantly, the emergence of natural sciences, of which Hobbes himself was a great devotee, and the invention of a state with, as we all know, the occupation in America, South America, Asia, and North America of new land and the development of capitalism. Now, in the 21st century, we have exactly the same thing, and we have as many controversies of a natural order. And the break of civic order this time is about what do we do with the ecological mutation? How do we handle the political disorder that comes with the question of nature? And we have all the disputes about religion, in addition to the dispute about science, the most famous of one being the pseudo-dispute around the question of climate in the United States. And we have a great doubt about state sovereignty. The best proof, actually, is the absence of Taiwan in the COP21st, and all the COPs, actually. It means that the most important and some of the most important actors are not represented. So the notion of sovereignty of nation state, the very notion which had been invented in the 17th century, in our tradition at least, by Hobbes, are of course now in jeopardy as well. So this is the situation where we now are, and that's the one which is extremely troubling and explains the disorientation. So the second part of my talk is now, what do we do with this? How do we handle, at what scale are we supposed to absorb this new situation of the ecological mutation, and how can we sort of generate a notion of being on this earth around the notion not of nature, not the notion of nature with a capital N, but the notion of composition. And I will explain what I mean by that. The problem is that we have a notion when we deal with ecological question which is about the globe, that is global. We hear a lot about global. We have to, whenever you talk about an issue like climate, pollution, industry, work, etc., immediately you are imposed the notion of a globe as a concept. The problem with the globe is that it never did, it never does its work of unifying the politics that it's associated with it. In other words, when you say a problem is global, the best you do actually is you do this gesture with your hands, right? Every time you say something about a problem, people say, yeah, but it's a global problem, and we do this with their hands. But global, see, that's the size of a pumpkin, approximately, right? They never go further than that. The word is not a pumpkin, and it's not a sphere. The notion of global is actually a very, very poor notion of the way we have to compose the earth. And that's what I'd like to say in the second part. In other words, this is a drawing I'm doing with an architect friend of mine, actually, looking for a figure of the earth that is different from the notion of a globe. So I'm told by the translator that globe and earth might be the same word in Chinese, but here, please make the distinction between the figure of a sphere and the figure of the earth as composed of many interlocking heterogeneous elements, so that we don't immediately identify the notion of the earth with the notion of a sphere. And the reason for that is that we use in the word globalization two completely different meanings. And I was actually discussing with your president a minute ago about that. So we have a simple example here. The first meaning of globalization, which is a traditional notion, it means that we have a system of coordinates and we multiply, thanks to it, the vast variety of elements in the world, which is the good notion of a globalization as a multiplicity of differences. But the problem is that in the last 30 years, we use globalization to mean exactly the opposite. We use globalization to mean the extension everywhere of a highly provincial definition of what it means to be doing economics or running universities or evaluating professors. So we were discussing with your president a minute ago the complete silliness of extending to the whole world one single system of standardizing professors' evaluation by the numbers of papers, which is the most ridiculous way of evaluating professors. Professors themselves having the most absurd ways of evaluating their own students by grading them, but that's another matter. I'm against grades in general, but it doesn't matter. Anyway, you understand that it's completely different if you call globalization the multiplicity of differences or the imposition of one single standard about what it means to evaluate people or university or economy everywhere. So you never know when people talk about globalization, when they say I'm against globalization, which one? Are they against globalization one, which means it's unfortunately the case in many countries in Europe, let's close the borders and let's just be very different from everybody else? Or are they against globalization as standardization everywhere of the same format, which is good? I mean, we have to fight this fight, of course. So that's one of the reasons why we are disoriented again. And that's why I want now to introduce, in order to find an alternative to the notion of the globe, the hypothesis which has been proposed on the left side by James Lovelock, who is a chemist, and on the right by Lynn Margulis, who unfortunately died in 2011, who is a biologist, great specialist of cell history. The notion of the hypothesis of Gaia. I don't know how familiar you are in natural sciences with the Gaia hypothesis. It's a very important notion for me because, first of all, it's a biochemical idea which will have a great influence on our understanding of the fragility and importance of the Earth, not as a globe, but as a system far from equilibrium. That's the original, one of the original data, so to speak, that Jim Lovelock used very early on to describe the Earth as a disequilibrium, this time in the thermodynamical sense of the word, compared to the other planets. Very simply, he said, he was in Pasadena at the time when people were trying to send rockets to decide if there was life on Mars. And Lovelock told them, they didn't like that too much, you don't need to go to Mars. Mars is in chemical equilibrium. There is no life there. If I was, and that's a very important thought experiment, if I was on Mars looking at the Earth, I would know immediately, without going there, that the Earth is alive, is kept alive by many, many living forms because of a chemical disequilibrium in the repartition of this chemical. Carbon dioxide should be 98, it's 0 at the time, 0.03. So it's a very, very powerful discovery by Jim Lovelock in the 1960s that there is something strange in the way the Earth is simultaneously misunderstood by scientists, understood by people who are using cybernetic thinking like he was at the time. As you know, cybernetic in the 1960s in California was very, very popular. This is actually the first drawing he did on the Gaia hypothesis, which is to try to understand not the Earth as part of a universe, so to speak, but as a highly specific, very special system which is far from equilibrium. That's the chemist view, which also means very fragile. which is what has some importance for the political reasoning, which I want to develop in the end. So when people began to be interested in the Gaia hypothesis, they in fact very quickly misunderstood it, because they put it immediately in the already there, already prepared scheme of a sphere, of a globe. And they say, yes, yes, we have understood. Gaia means an organism. Gaia means a complete system which is alive, and the Earth is alive, which is, of course, a very old theme which is coming from Christian theology, and I'm sure you have the equivalent in China's philosophy about the balance of nature. Where nature is well organized, it has a balance, and humans are putting it out of whack, which had a very unfortunate consequences for the Gaia hypothesis, because it meant that people misunderstood what was so original in the description that Lovelock was offering of a planet, that it has no organism. It's not an organism. It's not a whole. It has nothing to do with a system. It's something which is much more surprising than what it was doing. And here I need 5 minutes to describe, this is Lovelock in the old days with his wife. Lovelock is, I need to do that because he's often misunderstood. He's a great scientist, but he's first an engineer, and that's important for this university. This is a case of an engineer. He was trained as an engineer, as a chemist, as a physician, medical research, and the whole discovery that he made was due to the fact that he was inventing precise instruments, so precise that he could become an independent scientist. He never had to write grant application. Can you imagine that? The great thing, never have to write a grant application. Imagine a real scientist in a way. Things of the past, basically. Because, why? Well, because he could be paid by all sorts of big companies, which is interesting because he's considered as the father of ecology, but he was actually paid by all the bad guys of oil and coal industry, Exxon and BP. Why? Not because he was himself a bad guy, but because he had an amazingly exquisite instrument that could detect at parts per millions and parts per 10 of million pollutants. So he was introduced into the field of biology by the precision of his instrument. And basically, he was discovering in the 1970s now a very important phenomenon. If I can, with my instrument, detect very, very, very tiny parts which are produced by the industry everywhere on Earth, why not considering that the life forms, not only the humans, are able to produce also all sorts of transformation in the chemical cycle all the way in the history of the Earth. So it's not the feeling that there is one organism and that the Earth is alive. It's a different story. It's that if we begin to understand human influence on Earth, humans are doing what all of the other organisms have ever been doing on Earth as well. So this is why he's going to move from an organicist definition of the Earth to a compositionist definition of the Earth. And then he met Lynn Margulis. Lynn Margulis was, by the way, the wife of Carl Sagan. Maybe some of you remember Carl Sagan, who was very influential in the space travel. And Lynn Margulis had herself discovered all these things that we now learn in biology, that the cell, that every single cell is actually a population of other organisms which have been co-opted in the history of evolution to be partners, so to speak, in the cell life. So Lynn Margulis was doing at one scale what Lovelock was doing at the other, and that's the argument that they made of Gaia, not as an organism, not as one big organism, but as the overlap of many different types of entities, which together, without intention, without providential intention, are actually producing the Earth on which we live. And basically, there is a clear and very interesting link with another inventor, another great scientist, Galileo, which I think, maybe people say I exaggerate by putting Lovelock in the comparing with the great inventors and the great physicist, inventor of physics, Galileo, but I think it's perfectly clear. Galileo basically invented a regime, an epistemological regime, if you want, on the left side that viewed, and that was his great discovery in 1609, that you could consider all of the planets being part of the same universe in the same space, the Earth being just one among many. So the great discovery, which is celebrated in many philosophy of science, celebrated in history of science, is Galileo's discovery that the Earth is just one in the middle and that nothing special about the Earth, that the Earth is just one planet among the others, viewed from nowhere. And Lovelock is interesting for me as a parallel. You see here the cover of the first book, A New Look at Life on Earth, because it's exactly the opposite. You look at the Earth precisely as something which is so different from all of the others that it has a specific type of transformation by life form of all the geochemical cycle. So it's completely two different discoveries coming in a very different period. Both are engineers. Both are also very interested in publishing in their own language. As you know, Galileo published in Italian, and Lovelock publishes most of his discovery actually through books, which in science is not done. If you are a real scientist, you don't publish books, you publish articles. But Lovelock was precisely popularizing, if you want, his discovery, which were sometimes resisted by, readers. So the interesting thing in the notion of Gaia is not that it's an organism. It's not that life, that Earth is alive. It's something for which biologists, philosophers, physicists, and chemists are still trying to rack their brain to try to understand what it is. It means that every single element in this room and everywhere you have been is mediated, modified, transformed by life form. It doesn't mean the Earth is alive. It's the same as a termite mound. If you look at a termite mound, this is dead. This is a Taiwan factory. This is a beaver's dam. So it doesn't say the beaver's dam is alive. It doesn't say the factory is alive. It doesn't say the termite mound is alive. It says every link, every tiny piece of dust, every piece of mud or wood or industrial artifact there is mediated by life forms, and in the last case by human life forms. So this is the very interesting aspect of a Gaia theory, which is not an argument about organism again. It's an argument about the fact that every single thing we live in is depending on life form. As you all know, the oxygen in this room is entirely made by plants. So without plants, you're dead. I mean, I'm dead too. So and what is oxygen? It's basically the pollution made by plants. So we just drink and breathe plant pollution, if you want. Plant shit, if you wish. We are made of plant shit. Without that, we would be dead. Where do you put that in the definition of humans and the definition of nature and the definition of the universe is very difficult in our tradition. It might happen, but in Chinese tradition, it's slightly easier to think. In order to understand this very strange aspect of an Earth which is not a planet, which is not a globe, which is not an organism, which is not out of us, a place where we simultaneously, like in the termite mound, are building the whole world, and the whole world is depending on our action. Some of the scientists I'm studying, basically geochemists, call it critical zone. And the translator has found many different ways of translating the word critical. Critical zone is interesting for me as a concept of science, but also, I want to finish on that, on the notion of the distribution between science and politics. So you have to hear critical in the classic sense of fragility, but also in the thermodynamic sense of being far from equilibrium, and also in the notion that it's critical because it's an intermediary zone between different parts. So let me explain. This is the scientific definition by Tim Lenton. By the way, Tim Lenton is a great follower of Lovelock, one of his many students, few students. I think that's really the only student. Lovelock had no student. No grant application, no student. Can you imagine that? Scientific paradise. I'm talking here for academics here. For many Earth system scientists, the planet Earth is really comprised of two systems. The surface Earth system that supports life and the great bulk of the inner Earth underneath. It is the thin layer of a system at the surface of the Earth and its remarkable properties that is the subject of my work. The only thing here is support life, because in the real Lovelockian argument, it's life that is supporting the Earth system. But you understand the point, is that when we talk about the whole Earth, we are actually simplifying the system too much. We don't pay enough attention to the extraordinary complexity of a thin layer, which is a few kilometers up and a few kilometers down, where those guys coming from soil science, hydrology, geochemistry, biology, of course ethology, are trying to work together to understand this zone precisely, this zone of high complexity, which is what they are studying. The difficulty is to trying to find a visualization of this critical zone. It's not the globe, so we are not considering the whole globe. It's not the same concept as the planet. It's just the pellicule in which we all live. And the funny thing is that the only thing we know. We never left. Even when you are out of space, you are just connected by a technical system to this zone. I mean, the only thing we ever experience, we humans and life form, is there. And yet, we have difficulty imagining it because we always have, when we talk about the Earth, the view from outside, looking at the planet from far away. So it's actually very difficult to visualize. And I'm mobilizing lots of artists and other people to try to understand how this thing works. So it's a very interesting part of the Earth because it's the most heterogeneous. It's amazingly heterogeneous. It means that every water basin, every little trenches, every little village, every little farm has, in a way, to mobilize, to compose. That's why I use the word composition, a lot of discipline in order to understand how it functions, how it can be made. And it has all sorts of scale, from the very small scale to the large scale. So the critical zone is a different way of approaching the connection between discipline and natural sciences, but it's also, of course, because we live in the Anthropocene, the place where you have all sorts of other parties, because you have humans with their farm, their agriculture, their urban life, and their industry. This is an interesting case I saw yesterday, thanks to Nicolas Bouquet here, which is a museum in, well, near here. Sorry. You all know that, what the critical zone is, because you are on it. I mean, the word critical here in Taiwan means something which is extremely understandable because the Earth actually is like this thing. It just it just trembles, right? It actually quakes. So you know what a critical zone is. I'm not talking about the politics here. I'm talking about the Earth. Okay? But the great thing here in Taiwan is that you also have a political earthquake. Okay? So you have the amazing thing on the left is that I learned that yesterday the plate is actually moving 7 centimeters a year, which is amazing. And so you have all this museum, like the one on Earthquake Museum and the other one on quite extraordinary Chelungu Fault Preservation Park, which is a sort of pan to the greatness of soil science. So my heart was very moved by this museum, because this is a whole museum made because scientists digged a very beautiful case, a fault line, and discovered a lot of things about how quickly the Earth system is being modified in Taiwan. So I can go quickly on what is a critical zone. But not everywhere we have this amazing knowledge about the Earth systems. And here is a case which I am studying in South Sierra in California, which is a tree which is the most scientifically equipped tree in the whole of California, in order to understand how a tree functions as the water and the chemical cycles. So you see, we are so ignorant about this critical zone that we had to elect one tree for whole California, super equipped in order to begin to understand the whole dynamics of the influence of this tree on the geological and geochemical cycles, and reciprocally how in this case it was last year with a great drought, the quick transformation of the Sierra because of a drought. Now they move from drought to flood, but this is what the new life will be, the new normal. It's like here. Even here you might manage to have drought, which is quite extraordinary. You are not used to drought. So the whole knowledge we have to acquire in order to begin to understand on what critical zone we reside is immense, because in a way we know much less about the land on which that we inhabit than we know about health. So we are super equipped to understand how our body functions, and we are super not equipped to understand how the critical zone functions because of their amazing heterogeneity. So suddenly we realize that if we want to land on Earth, as if we were out of space and we want to land on Earth, if we ask the question where we land and how do we visualize the place where we land, we are very ill-equipped for that, because of the high complexity of a place where we sort of haphazardly put our industry here or there, and without realizing how difficult it is actually for the Earth. So I'm trying to imagine a whole series of inquiries on how to reassemble, so to speak, the Earth's thin surface. This is a drawing by my colleague Alexandra Arend, trying to follow scientists and how they visualize these very thin layers, and the amazing numbers of instruments they are trying to put together in order to begin to fathom the complexity, as if basically we wanted to transform the Earth in, how do you say that in English, when you are sick, you are transported into urgence, care, intensive care. We have, basically, that's the goal, is to put the Earth in intensive care unit. And you need a lot of instruments in order to understand everything from slope, from every geochemical cycle has to be understood anew because of the amazing heterogeneity, which is not the case before when we were seeing in the Galilean notion the Earth inside the universe. So to conclude, this is a bad diagram, but I couldn't do better. What consequence does it have for the link between science and politics? Because after all, I'm coming from a field of science and society, and what I'm trying to do in this diagram is trying to give you the idea that there might be some progress to be made if we were differentiating several parts of our natural sciences and reserve a different epistemological status, so to speak, for those who are in this brown circle here, this thin pellicule I call the critical zone. So imagine that what is inside the circle is the study by geophysicists of the inside of the Earth. Everything they know is coming from instruments, seismic instruments, geochemical instruments, which they need to build in order to know anything about what is inside. As you probably know, if you are a geoscientist, below basically 10 or 20 meters, everything has to be instrumented. There is no way you access it except in a few trenches like the one we saw yesterday. Now, about space. Everything we know about space, you need instruments. Everything we know about out of space is highly accessible, but only through powerful instruments, from telescope to rockets and so on. So we have two sides. So now what I'm asking you is to differentiate in the whole natural sciences those who are dealing with instruments inside the Earth and outside. Why? Because the difference in the link between those two is that even though they can be disputed in terms of policy, should we put money into a new telescope, should we put money into a new probe, they don't interact with many other parties who would be disputing their result. If you say, I disagree with what the astronomer says about the origin of the universe, people will say, sorry, but are you a physicist or an astronomer? If you say, no, I'm not an astronomer, people say, okay, fine. Wait, I mean, we are not interested in your discussion. You cannot debate, you cannot mount a dispute with astronomers about that. Same thing if you are saying, well, I'm not convinced there is so much iron in the middle of the Earth. People say, are you a geophysicist? Say, no, I'm a philosopher. Or no, I'm a farmer, or something like that. People say, okay, well, we'll wait, have another beer and stop talking about this thing. But that's not the same situation for every scientist, engineers, philosophers, social scientists, anthropologists, hydrologists, soil scientists working on the critical zone. Why? Because there they have infinitely great numbers of other people, other interests who have completely different notions of what they do and what you do. So there is a zone, sorry, it's a bit barbarian, but I call there is a zone of epistemological conflicts on the critical zone, which are very, very different from the others. And the best proof of that is the climate science dispute. I'm not talking about the false pseudo dispute about the quality of the research in climate sciences. I learned that Taiwan is protected against this folly which has invaded the United States and unfortunately part of Europe. But about very simple things is that whenever you make a scientific statement about anything connected to the critical zone, and I remind you the critical zone is everything you have ever observed, and this is where you live. You don't live in outer space. There will be people who will say, this is a value statement. Even if it's a completely objective, instrumented, and well-asserted fact. If you just utter, as a geochemist, there is 400 parts per ppt of CO2 in the atmosphere, people will say, oh, you want us to transform our way of life. Even though you say, no, I mean, I'm just saying we have 400 ppm of CO2 since last year, as it has been measured in Hawaii. This is a fact statement which by necessity will be understood, especially by people in the oil and gas and coal industry, as a value judgment, because it necessarily builds a line for policy as well. It doesn't say which policy, but it will be seen as an intervention into a policy question. And if you say anything about the way the soil will be moved and transformed by the climate new condition in Taiwan, people in development, people in real estate, people in farm will say this is a value statement. And they will ask you either not to speak about it. In the United States there are a few laws not to talk in Florida about the raise of the ocean. You are forbidden by law to ever mention, if you are an official of a state, to mention that the ocean is rising. Or people will say, forget about facts. Let's abandon every evidence. We don't want to hear about it, which is Mr. Trump line. But there is something true in this dispute. Not that the dispute is objectively true, we know a lot about it, but the way, what many scientists, and I insist on that because I've taught in an engineering school for 25 years at the School of Mine in Paris, and I know it's very difficult for engineers to accept that their statement of fact is disputed or immediately considered as a value judgment. If you don't want to be considered as in doing value judgment, you have to talk about the outer space or the inside of the Earth. If you talk about anything in the critical zone, a lot of you probably do, when you utter a statement of fact, you have to be prepared and accept in some ways that you will be disputed, not just because people are idiots, which is often the reaction. We say, okay, this guy don't know anything about it, forget it. No. You will have to enter into some sort of politics. And that's, of course, the whole idea of the field of science and technology studies. It's the sheer impossibility in the case of critical zone research to make the distinction, to maintain the distinction between fact judgment and value judgment, not because your facts are corrupted, but because people will hear those as value statements. And they will be right. Because the question is that we have to compose the world. And by necessity, when you study something where there are so many overlapping interest parties, every statement of fact is actually a statement of values as well. And that's a very great problem for university organization and institution, because many times scientists, probably not in this benighted university of yours, but many times engineers are completely unprepared to be criticized on the ground, which would require the building of an institution of debate, so to speak, for which we are not prepared. So most of the time they just grumble and say, I'm talking to idiots, they don't understand anything, or this is just politics, why do we hear all these people? But that's not possible. Look at what happened to American scientists. They had defended the best science on climate, and now every day we learn that their money is cut by people who say, we don't live in this world, we don't want to hear about ecological mutation. There is even a law which is going to be passed by Congress, which is amazingly enough called For a Fair Science, which means that scientists will be forbidden to be in the committee allocating money for research on climate. Why? Because scientists are biased. Of course, they defend their science. They are a lobby like another one. So these people are so obsessed by the denial of facts that they actually want to deprive scientists of the access to the value judgment on their own research. Anyway, this is America. This is not, fortunately, it's not Taiwan, which is much more advanced. But the last word I want to say about that is that in the Greek tradition, in our philosophical tradition, we have one concept which we could work, I don't know about the Chinese equivalent, which could work to isolate, to differentiate in the whole natural sciences those who have to deal by necessity with political disputes, which is the word physis. Physis was the old Greek word, Aristotle used it, to describe the movement, to describe what I think in my little Chinese is called shi, propensity, the movement of the transient movement of every entity. And then when Galileo came in, the invention of Galilean object deprived entirely physis of all this movement, and it becomes nature of the universe. And I think there is a great interest for the link between social science and natural sciences to reuse a word where you say, no, yes, I'm a natural scientist, but I'm a physis scientist, or I'm a she scientist. I don't know if it works. She. Well, okay, we'll see what I mean. So it means, it means that we are going to have to compose connection between types of knowledge which will be disputed by nature, so to speak. It will be necessarily disputed. And I think that's what I wanted to talk to you. And I'm very grateful to have been able to talk with you. And this is part of an argument which I developed in a book soon out in English called Facing Gaia. Thank you very much.